a shift in all climatic activity. So I'm not going to go deep into the science of it because I can't really go deep into the science, but causing it global warming is just not quite accurate. So they stopped doing that and they started calling it global climate change. Now, where people get in an argument, and this is not a lesson about climate change, but I know some people are still pulling in their plan books or things like that. And I'll pass out the other papers because I didn't even put up there to get today's paper. But where people get in an argument is climate change will happen naturally with or without us. Planets go through cycles of heating up and cooling down. We are exacerbating the issue. We're making it happen much faster. So that's the problem. There. If I see it again, it's mine. So put it away somewhere. 7.21. Should be in the bin. Or not the bin, the binder. Okay. Right there. Anyone else need anything else from last week? Going once. Like you missed something from last week and you need it.
Oh, I don't think I have 7.3. Well, I think he said that he was going to pass for them.
No, you should have 7.3. It was from Wednesday.
It's 7.23.
7.2.3. Today's paper. Today's paper. If you need, I will bring you one. You need today's? Yeah. Today's paper. Today's paper. Do you have today's paper?
Oh, I have it. In my head, I was saying 7.23.
Who still needs today's paper?
Oh, I need it.
And you need your resource page out from last week. I don't care if you already have the work done. You need your resource page out. Who else needs it? The resource page, I think a lot of us use highlighter on to track who was going faster. On the front of it. Oh, it's stuck here. Oh, no, it's not. It's this. It's biking the triathlon and finding slope. Biking the triathlon and finding slope. Unless you grab the one that doesn't have a back, and in that case, come grab a different one. There was one master copy that maybe didn't have a back. Anyone else still need the resource page? We didn't do the back yet. It's for today. Alright. I don't even know how to respond to that. Because I don't want to say I swear I don't trust you, because I do trust you. But if it was clipped in your binder, I don't know what would have happened to make it not be there. It's both. If you need this, you can have it.
And it all comes out.
Alright, because I know you all are just so excited to be back in my room with random cards. Simon, what can you tell us about slope? Just give me anything. One comment about slope.
Slope is the amount of time it takes, for y to change by, it's how much x changes for every y, or how much y changes for every x?
Yes, because you said multiple things. Audrey. Do we have Audrey? Yes, that Audrey.
Oh!
Hey, look at all. I know.
Slope is like the increase.
The increase. Is that all you got?
What?
Is that all you wanted?
Yeah, it's only one.
Other Audrey. Nope, slope. You can relate it to apples.
So it's the amount of time it takes for you to eat a bunch of apples.
Sure. We could compare how many apples you can eat and how long it takes. Alex? Hi.
For what slope is?
Yeah. Wait, who'd we just lose? Don't go! Who was it? Leah, no, stay here. Just for a couple more minutes because we're going to write something down.
The independent variable that affects the y-axis.
Ooh. Independent variable affects the y-axis. Ellie, what do you think?
Well, people got really deep, but my original, I was just going to say that it can be measured by rise over run.
Crystal? The growth? Patrick?
The amount y grows by of an x.
Very, very good thing said there. Now I got to the card. That means I can shuffle. So, slope can be described in a lot of different ways. There are a lot of correct ways to talk about slope. Unfortunately, one of the wrong ways to talk about it right now is skiing because, well, it's like 50 outside and there's no snow and sorry, ski club is canceled. But, what? Yes, okay, but we're not driving to Michigan tonight. I just feel bad that ski club is canceled for some of our friends here. So slope on your graph paper, because everyone should always have graph paper out. The regular was still on there. It can be yesterday's graph paper, and by that I mean Fridays or Thursdays or whatever the last day you worked on graph paper was. Slope in the easiest way to remember the definition. Rise compared to run, or rise over run. Slope in different representations, or slope. You just call it slope. For all I care, your notes can just be titled slope.
Oddly satisfying to me.
I know, right? Because it makes the negative space. What is satisfying is seeing the background disappear. You know what I mean? As opposed to like. So slope is rise over run, which technically, as somebody else contributed, is delta y over delta x. And yes, to those of you saying, we've already written this before, you're right. But a lot of you couldn't, like if I gave you a pop quiz right now, you couldn't answer this for me. And I don't know why I see some people holding up their heads instead of writing this down. Because we will have a mastery on this at some point this week. And that, if we want to get technical, and guys, we have not written this very many times, so I would write this down if I was you. Y2 minus Y1, oh, I'll tell you, over X2 minus X1. Now, because I think I might get a formal complaint registered to Dr. Bowers if I don't call on Alina. Alina, what do you have to say?
Can I explain it, please?
I don't know, can you?
Yes, I can. No, may I explain it?
Sure.
Okay, so let's just say this is a graph, okay? Okay.
What, you're all aggressive.
Yeah, let's just say this is a dot, and then this is a different dot. So,
Different dot?
Oh,
I know it
is. So this, let's just say this is y. So this is like.
Careful. Keep going, but just careful.
Okay, this is. Let's just say this is 4, and then this is like 2 or something.
Oh, it doesn't matter what the number. Don't give it numbers.
Well, yeah. So the y about this value right here is y2. So it's.
Now you're getting messy. Let me jump in. You're not wrong at all. You want to keep talking and I write, or what?
Yeah. Sure.
Okay, you keep talking, I'll write, because you're getting messy. Keep talking.
What?
Oh!
Okay, so yeah, that's this dot is like the second dot, and this dot is the first dot. So it'd be x1 and y1 because this is the first dot, and this would be x2 and y2 because that's the second dot. So y2 would be right here, and then x2 would be right there because it's like the same dot, and then x1 would be right here, and then y1 would be right here, and then you subtract them. So yeah.
And here's the trick.
Yeah.
It doesn't matter which dot is which. She was right. We can call this the second, we can call this the first, or we could call this the second and call this the first. It doesn't matter. You just do y minus y, x minus x. What does matter, is that we go in the same order. If I do this minus this, then I have to do that minus that. If I do this minus this, then I have to do that minus that. I just have to go in the same order. So, when we talk about slope in different representations, those points that Alina was oh so accurate about, this, this pointy thing, whatever, we call these lattice points. Does anyone know why we call them lattice points? And they're not just willy-nilly. I can't just like, oh yeah, that, boom, there, lattice point. I can't just do that. Henry?
Because they intersect with the line.
They are points that lie on the grid. So, as Henry just said, they intersect with the line. They're points on the grid that we have, right? These intersection points that we can easily name. Well, hey, look, another lattice point, because it's a point on my grid that lines up with my line, like perfectly accurately. And that creates what we call, that we're all very used to now, the slope triangle, right? Like we worked with the triathlon problem last week. So, if we look at this set of graphs, let's just do 1 through 4 for right now. What are the slopes for each of these? Take a couple minutes, chat with your partners if you need. If you want to go the extra step, what is the entire equation? If you want to go the extra step, what's the entire equation of the line? You have this on your resource page.
Oh, we do.
So find the lattice points. I would write them down if I was you. For all 4. Really, I think there's 6. You can do all 6. If you're not quite sure if a point is a lattice point, go further. Are we okay?
Yeah.
You sounded like an old-timey police car.
I just realized how rise over run works.
Like just now, in this moment, your whole life changed. I can see clearly now the rise and run. No, but we could make it.
When Raleigh said that he moved out of his brother's room because they were living together, so I immediately made a parody of Let It Go.
We should be finding points on our line that intersect some grid points. Because there are other points on the line that don't intersect the grid points, and those aren't as useful.
What is it
I won't say they're worthless, but what?
What is it graphing?
Things. Height and time, height and time, height and time. Trees. I don't know.
Trees? No, apples and trees.
Yeah, 10-meter tall human.
Wow.
Yeah, they're like 5 years old. 10 meters tall at 4
Now, some of you might find this excessive, but guys, one thing I've realized is it's easy to accidentally switch up your X and Y. So, here's how this is going to roll, and to incorporate a lot of you guys. For each of these, I'm going to ask, and keep working if you need to keep working, I'm going to ask for 3 of you. First person is going to meet a point. Second person is going to meet another point, like lattice points on the line. Third person is going to tell me the slope.
Wait,
Okay?
like of the line on the paper?
Because the slope's the same. No matter what lattice points you used, if we did it right, the slope's the same. And actually, lattice point 1 and lattice point 2, they don't have to, like, as long as they're both on the line, they'll have the same slope. Right? It doesn't matter if you use those 2 points or if anybody used those 2 points. Because honestly, I could go down here and use a negative point. I don't think anybody used, but I could.
That's true.
Alright, let's see how much of this deck we can get through. Liam, give me a point from I. Or the first one here.
2, 3. 1, 3.
1, 3. Alina, give me another point. 2, 5. And Avi, Xander, Serena. What's the slope there?
1, 3.
That's a point. Ooh, close.
2 over 1.
It is 2 over 1. It's the y over the x. We can also draw the triangle if we want. We could draw a much bigger triangle if we want. But when we simplify it, our slope, which we talk about as our m, is 2 over 1. Now, did anybody go the extra mile and find the full, Crystal, what's the equation there? Why? How did you get your plus 1? Boom. Y-intercept is how you get your constant. Thank you so much. Mr. Dale, give me a point from the second one.
Second one, that's 2, 3.
2, 3. He didn't even cop out and use the easy one. Oh, yeah, it was an easy one.
Oh.
Patrick, give me another point.
0, 0.
Oh, man, 0, 0.
Really?
So then, Bear, what's our slope there?
3
3
over 2.
over 2. The rise, trying to get to the y. The run, trying to get to the x. Now, we can do the formal 3 minus 0, 2 minus 0. Or, guys, if we can just see the growth that is happening, if we can draw a triangle, it makes our life so much easier. Did anyone get the full equation here? Hazel?
Y equals 1.5x.
Y equals 1.5x. Or we could have actually left it as 3 halves x. I kind of like improper fractions better. It's up to you. But this is easier to graph. Think about it. Go up 3 over 2 as opposed to if it was 1.5x. That's still right. I'm not saying anything's wrong with it. It's just a little harder to graph. The improper fraction is a bit easier to graph. Go up 3 over 2, make your next point. Up 3 over 2.
You can have your own opinions and I will have mine.
Absolutely. I'm not saying there's anything wrong with it. I think this is better. Now, would I mark yours correct? Of course I would. Because 1.5x is true. Simon, what is a point we can use in triple I?
I use the point, let's go, here's one, here, let's go 9, 6.
Yeah, 9, 6. Audrey, what's another one?
0, 0.
Aha, the origin, meaning our slope is origin. Our slope, other Audrey. God, I gotta shuffle these.
Oh.
I did shuffle, but 3 to 2. No, wait, I thought it was 9 over 6.
Oh. Now, I did the wrong one. Oh, it's 3. It's still 3 too.
Why?
Because you simplify.
Yes. 9 over 6.
I was like, what?
Now, wait a minute. Wait. Is this line parallel to that one? Because we just had 3 halves.
It's 2 over 3.
We're upside down. This eyes. Got some eyes that aren't up here. This is the trap door. This is the trap door. And that's why when you said 3 over 2 or whenever anybody's, maybe I just wrote it. This is the trap people fall in. They put their X on top of their Y. It is not X over Y, it's Y over X. This is 6 over 9 or 2 over 3. Be careful. That's the trap door. Which makes this Y equals 2/3 X. Henry, give me a point from our last, well, from number 4 here.
Okay, number 4 would be 0, 4.
Ooh, I like it. Using that Y intercept. 0, 4. Ellie, give me another one.
6,
6, 8. What's our growth to get the Y where it needs to be? Okay, that's a 4. And what's our X growth?
4.
Well, depending on what triangle you set up, right? So here our M is 4 over 6 or 2 over 3. But, Charlie, what's our equation here?
It is y equals 2/3 x plus 4.
I think you guys are totally ready for the activity tomorrow. Hey, so before we move on any further, let's talk tomorrow so I don't forget to do this.
Wait, we have to do the same thing to the first one. We never added the 1.
What?
First one's done. We
Yeah, we did. You just missed it.
2x plus 1 is.
Let's talk tomorrow real quick before I take any other questions. I will not be here tomorrow. There's a guest teacher assigned. Yeah, trust me, I don't want to be gone. I have to go to Upper Arlington to get like 3 different scans done. Then I go on to OSU Ross Heart Hospital. It's my heart. The same stuff that's always been going on. So they're gonna scan me a bunch of times, put me in an MRI machine, make me deal with a whole bunch of crap, then send me down to OSU and tell me, hey, nothing's changed. Right? That's essentially what happens every single year. But they want to keep tabs on it because you know your heart is kind of important.
I mean, if
Sort of.
something changes,
Right.
they want to know so they can help you.
Exactly. So they're keeping tabs on me, right? It's like my heart is progressing, but it's okay where it is, right? They just want to keep sure make sure I haven't slipped down to like not progressing, right? Like gotten any worse. No. If ever I need to have surgery, then we might call it master. But so tomorrow you will have a Desmos activity. It will be familiar to you, but the last time we tried it, I think a lot of us got pretty frustrated because we weren't quite sure what we were doing. It's the one where we try to land the plane on the runway and like do it accurately without just guessing a bunch of times. So if you didn't see it, that's okay. I think it was one of those days where it was like, if you get done with this, try this one. And I was just like having you kind of sample out Desmos stuff. So it involves slope and y-intercept. If you are still sitting here not understanding what slope and y-intercept are, this activity will be tough for you, but it will also be a growth opportunity. So, as always, be cool to the sub, give them more respect than you give me, and leave the photo roster with them, and you don't want your name written down. Those conversations, and a couple people have had those with me this year, the conversation of why did the sub leave me a note with your name in it is not a fun conversation to have, right? And sometimes it is, I am calling home to say, hey, just so you're aware, when a guest teacher was in our building filling in, and we don't have enough subs, realize that Mrs. Goldring didn't get a sub today. That the guy who filled in Clay from over at Academy, he works at Academy daily. We pulled him from where he normally works because he's like an extra staff member to fill in. We don't have enough subs in this district. So we expect that you guys treat them really, really well so that they want to come back here, right? And actually, we care about you guys so much, we block certain subs from our school because if they're bad, we don't want them back here. So our Mr. Flynn has the ability to block people from our building. And I mean, straight up, if you guys tell us we didn't like them, they here, not because, they assigned us homework, they made us sit quietly, and that's fine. But seriously, if they don't jive with Phoenix, we don't let them come back here. But that makes it tough for us to fill our spots. So please be cool with them, because I'm out tomorrow for you guys, and I'm out Thursday. So I'm telling you, Thursday, I take my dog to have surgery. So, sorry, it's okay, but we got to get this thing biopsied so we can figure out what's going on. But again, Thursday, I don't have a sub yet. They haven't filled it. So I don't know what's going to happen, but I'm out. So be cool to our subs, they'll keep coming back.
How many years of schooling does it take to become a sub?
It depends on the district and their requirements. We have tough requirements. Essentially, you have to be a teacher to be a sub, and you have to have an education degree or something like that.
Would there be a way to do all that schooling in about a few months, in sub for Phoenix?
Nah, it'd be tough to make that happen. Henry?
So, how many subs have been blocked, and have any of them taught us?
I am not going to spend time answering those questions.
You're not sure? I take it.
I'm not sure, and I don't need to be sure. Because just if they're bad, you'd be thinking about this year, but I'd be thinking about my span of time at Phoenix. How many people have we said, okay, don't come back here? For what it's worth, just last week, we said, okay, maybe you don't jive with us. Maybe you shouldn't come back to Phoenix. It doesn't matter. You don't know them, and you probably won't see them again. Simon?
When is Mr. Roby's long-term sub?
Who?
Mr. Roby.
What?
Roby.
Oh, when is he coming back? I know he's in a long-term position, but he might end up in another one. I can't answer that for you. I don't control him. Trust me, I'd love to have him back. All right, so we need your help. 3 different students are having a very middle school-esque conversation, argument, whatever you want to call it. They conver argument. Convargument. So they have gotten three different answers, right? Student A, student B, and student C both think the other ones are wrong. I need you to figure out what are students A, B, and C each individually saying, and are they actually having an argument?
They're not.
Take 2 minutes, random cards, figure out what are these slope triangles that A, B, and C set up. Again, this is on your resource page. What are those slope triangles? Why are they arguing, and why is this silly? You guys can write all over this stuff. You can darken it, you can highlight it. What's A's rise and run? What's B's rise and run? What's C's rise and run? Well, they're not all the same.
Yes, some of them all equivalent. Yes, what he said.
Remember when we talked about how you didn't know what congruent meant? And here you are saying they're all the same. They're not all the same. Similar versus congruent, right? Congruent would be same. Same, like you're using it, is not congruent. Did you look it up and figure out the difference? So what's congruent? You can just tell me. I need to remind you. It's okay. Congruent means same shape and same exact size. Similar means same shape, different size. So dilated, yeah, it has to be dilated essentially. Like it has to have changed size somehow. So I only have a couple more cards. Charlie, you have a question because your card just got pulled already. If you on the last one, yeah, you're on the last one.
I actually do have a question.
Okay.
So if something is similar, it can't be congruent?
No. To be congruent, it has to be similar. So this is like the difference between square and rectangle. A square has to be a rectangle, but a rectangle is not necessarily a square. Two congruent shapes are similar, but we don't call them similar because congruent is more accurate. You don't call a square a rectangle when you can call it a square.
Because square is more accurate.
Yes.
Okay.
So the issue with congruent shapes is they're similar by a scale factor of 1.
Yeah.
So we don't, like, that's silly. We just say congruent.
Yeah.
Because congruent tells you same size.
Okay.
Yeah. It's like wasteful to say it's similar with a scale factor of 1. So Ike, when we look at A's growth triangle, what did student A find as the slope? You had like almost 2 minutes to do this, man. My timer's almost ran out. Did you do this or are you just like hanging out? Do C, we'll come back to you. Logan, what's student A's growth triangle?
5x4.
Yeah, 5 by 4, right? 5 up, 4 along. I love that you gave me the Y first. So student A, which I'll write in blue, is saying it's 5 over 4. Student B, Elena.
B 15 over 12.
Ooh, 15 over 12. Somebody said he's just like an overachiever. I think I heard somebody say.
That's a lot of boxes to count.
Yeah, that is a lot of boxes to count, right?
Like,
And Ike, you got C for us, dude? Yeah, 10. Is it 10 over 9? 10 over 8, right? It's all good. Mondays are tough. So, Katie Ann, are these students arguing?
Wait, why are they or are they arguing?
I don't know. You
Well, they are arguing, but they're arguing about something stupid.
Okay, why? You do the best, teacher. You guys are being stupid. Stop being stupid. Okay, why is your argument stupid?
Because all of their answers are correct, because all of their answers equal the same thing in the end.
Which means those are all what? Ooh, I mean, yeah, but what do we call fractions that are all the same?
Equivalent.
Ah, these are all equivalent fractions. So remember, equivalent fractions are equivalent ratios. This is where, like, I'm giving Bear a hard time. They're not the same, but they are. Right? They're equivalent fractions because I could double to get my 10/8. I could triple to get my 15/12. But no matter what, if I reduce down, my slope is just 5/4. And this would be the best way to talk about slope in the reduced fraction. What's the y-intercept here? What's the y-intercept here? Simon?
It is 2.
No.
No.
2. What?
With a messy slope and this being a nice point.
1.8.
Do I move one box by one box? No, because my slope is not nice. This is close to 2, but it's not a nice y-intercept. So be careful. We don't need to technically figure this out right now. We could, but we're going to move on.
1.8.
It's 1.4. No.
10/4. That'd be over 2.
1.8.
This is at 1, right?
It's what?
Is that an x value of 1? I think it's an x value of 1.
Yeah.
So every x we lose, how much y do we lose?
5/4. Wait.
Y is 5/4 x. Right? So if we take away an x, we take away a 5/4. What is 3 minus 5/4?
1.8. No. Wait.
1.75.
It's 1.75. Sorry for those. I think Charlie was waiting with his hand up, but I wanted us to process through it. I didn't want you to say that one. So it's you don't need to know how to do this, but if we want, not yet. If we wanted to do the slope like we just did, we could just take a 5/4 off of this y value, and that's actually 1.25. Right? We take that away. That gets our y value. So. Actually, let me check this slide. Okay. Did we talk about simple interest this year? I really think we did.
We did that last year.
Oh, okay, yeah. Well, oh, yeah, because you guys are the Math 8 class. So, take a moment to look at these graphs. Now, first thought, Ryan's like, woohoo, buddy. I'm rolling in the green. Making lots of money off my interest. Interest is free, right? Like you just put your money in the bank and you make interest. So both Thomas and Ryan have put their money in the bank. They're both making interest. And Ryan's graph, he's like, hey man, my investment's better. Sucks to be you. Sorry, dude. Now, interest is just how much extra money they've made, right? So we're assuming they both start with the same amount of money. Well, no, that's interest earned, right? So their interest started at 0. Well, let's assume they both invest the same thing. I don't know. Look at the X's. Alex is making lots of noises. Scroll down. Logan's yelling at me to scroll down. Why are you yelling at me to scroll down, Logan? First off, your hair is looking great today. What is wrong? You got a nice swoop going on. What do you mean? What is wrong? I don't know what you mean. Give me more. Yes, Ryan is a friend of mine. He plays tennis. I'm gonna go to Henry if you don't spit something out.
Henry, you've got to. First of all, he has kind of a big ego, I guess.
Okay. Tell me something about math.
Second, so,
This is actually like third or fourth, but. What? What about the tables? Why'd you make me scroll down?
okay, so, for Thomas, the rate is 1 week is 60 cents,
Okay.
and, for Ryan, 2 weeks is $1.
Okay.
So, if you use that rate and if you divide that by 2 so that it becomes first week, he only gets 50 cents.
Oh, so you're saying if I divide this by 2, because that's, I can work it backwards, then 1 week is 50 cents.
You lied.
Or he's just not big brain.
Yeah, or he's just not big brain.
I was basically going to say that because the scale was different, that Ryan would actually only earn 50 cents a week.
Yeah, because the scale was different, right? So if we kind of track out where the scale lines up.
See, Thomas is a good man.
You haven't even met him.
You can't tell someone's personality about
You're relating things that don't necessarily relate.
Well, maybe Ryan actually does make more if he just has different
If I try to make that straight.
No, you haven't tried banking.
Yeah, that happens before 2 weeks, right? So if we just Hey, Liam, stop. If we just had the graphs, it'd be a little tough. But as Logan yelled at me to go down to the tables, once we have the tables that we can compare, now we could also look at this, right? It takes Thomas 10 weeks to earn $6. How long does it take Ryan? 12 weeks. It takes him longer to earn the same money. We could also compare that. Henry?
So, do most banks use simple interest or compound interest?
It depends if you're investing or if you're borrowing. Sorry, that's the most straightforward answer I can give you. If you're borrowing money, it's probably compound interest. It adds more interest onto the interest that you already owe. So you get charged interest on your interest. As opposed to just getting charged interest on your balance.
That kind of makes sense.
So, I'm about to pay this off. Hopefully really soon. But so to give you real life example about interest. Even if you don't care about the math we're learning, you might care about this. So, I renovated our kitchen at home. I didn't have the money to do it. But I do have money invested in my house. So what I did was I went to the bank and I said, hey, look, I own a house. You could take my house from me if you really wanted to, because I'm going to borrow money from you, and if I default on that loan, to default means you don't pay it for a long time. If I default on that loan, you can have my house. And they're like, okay, we'll take that deal, because shoot, it's a house, right? If I don't pay it back, they take my house. So, I get a loan. Exactly, yes. So I get a loan, and let's say it was for $10,000. It wasn't. It was cheaper than that because my kitchen was not that crazy and our kitchen's not that big. But let's say it's for $10,000. Let's say the first year I pay some on it. Let's say I pay $1,000 worth, and it comes down to $9,000. I'm being real simple here. Let's say at the end of the year, interest hits and it bumps it up by $100. That would be really cheap. Interest is more than that. But let's say it bumps it up by $100. Now the balance is $9,100. The next year will charge me interest on the $9,100 like that was what I borrowed. Although it wasn't. The $100 was interest they charged me, right? But it's still, they're going to charge me interest on that interest. That's compound interest. Does that make sense?
They charge it by the second.
Nah, it depends.
That's sad.
Normally monthly.
I like that.
Actually, some things are called continuously compounded, which are happening all the time. It's really funky math. All right, you guys got to get out of here. Sorry, Charlie, what's up? Yeah. Yep. Yep.
Then how do they prevent that?
But most investment accounts don't pay very much interest. That's the thing. You have to invest in like the stock market or something where your money's locked in there and you can't pull your money out as easy. You have to like sell a stock. You know, it's a little different. So like if you go open a checking account right now, you'll be lucky if you get 1% interest. Like, yeah. Like you'd be lucky. A credit card's gonna charge you 18 to 25% interest. Yeah, on you. Yeah, yep.